Okay, let's talk about congestion. Congestion can happen when the queue that exists in an interface becomes full. That is known as the TX queue or TX ring. And that can happen, for instance, if your ingress interface rate is greater than your egress interface rate. So for instance, if you have a 10 gigabit interface rate that is transmitting traffic and you have your egress interface is only 1 gigabit, you will have congestion there. You can also have many ingress interfaces and only one egress interface. And congestion can also happen in that case. The solution is using queuing and scheduling to solve that. So you can use the queuing. For instance, you can use FIFO queuing. With FIFO queuing, the first packet that arrives to the queue will get served first. Then the second packet that arrives will be served second, and so on. That is what first in, first out means. With round robin, what you will have is having several queues, and if you have packets in each queue, with round robin, you will be picking up one packet from the first queue and transmit it, then picking one packet from the second queue and transmit it, then picking one packet from the third queue and transmit it, and so on. So all queues are served in an equal manner. So Cisco came up with several algorithms, methods in the past years. For instance, you can have weighted round robin that breaks the rule of round robin, in which one queue can get served for more packets than other queues. You can also have a custom queue that used 16 queues with round robin and FIFO. And you can also have priority queue that had 4 queues. This was an interesting one because it featured one priority queue. So in this priority queue, you will place important flows like voice or maybe video. But the downside of this method was that as long as packets existed here, these other queues were ignored. So that brought something that was known as starvation. So these queues can become starved if there were continuous packets arriving into the priority queue. Then came along the weighted fair queue. That is really cool. It will detect your flows and it will put your flows in several queues. Then it will pull out packets in a very fair manner. It will pay attention to IP precedence, and you could configure it to have up to 4096 queues. So it was really cool, and it is the default queuing for routers. You can also use class-based weighted fair queue, where you can configure an access list, and then for determining your flows, then using a class, and then using a policy in order to provide certain bandwidth to certain queues so they don't run out of bandwidth, or maybe define one queue as priority, and if you do that, you are turning your class-based weighted fair queuing into low latency queuing. Now, how about congestion avoidance? In order to avoid congestion, the router can drop packets. So if the rate increases as time goes by, the router will drop packets using tail drop, but they will apply this drop to all traffic equally, to all flows. So that you will see is that all packets get dropped from all flows, and then something funny will happen. Remember that TCP detects this lost packets, and it will start retransmitting. But at it start retransmitting, it will start increasing the window size, and then TCP will start increasing the window size, and then will start using more and more bandwidth until the router notices that, and then tail drops everything again, and then it will drop packets, and then TCP will start increasing the window, and then when packets get dropped, and then TCP will start increasing, and you will have this kind of graphic where you will be actually not using this bandwidth. So that is not really a good solution, because you're not using all your bandwidth. There are better options, such as random early detection. Cisco offers weighted random early detection, where you can configure your router in order to drop more packets for certain flows and drop less packets for more important flows. You will have to define a point where you want your packets to start getting dropped, and a starting point, and the rate of dropping packets could be greater for some flows and lower from others. You can also set the explicit congestion notification bit with this method, and that's it.